Hi everyone, welcome to Programming 2 COP3337. In this lecture, I'm going to cover Chapter 8, Designing Classes in Java. Here are the objectives. We are going to learn how to discover appropriate classes for a given problem and understand the concepts of cohesion and coupling, and then how to minimize the use of side effects and to document the responsibility of methods and their colors with preconditions. So, first of all, it's important that we discover classes by looking at the problem domain. A class represents a single concept from the problem domain. The name of a class should be a noun that describes that concept. So, in math, the concepts like point, rectangle, ellipse, and in real life, the concepts like bank account or cash register are good candidates for the name of a class. As another candidate for discovering a class, you can think of actors, the nouns which end in er or or. You know, actors are objects that do some kind of work for you, like a scanner or random generator. And also, there are some classes which have no objects and are they only contain static methods and constants. These classes, which we call them utility classes, are a specific type of classes. For example, math in Java is, a utility class. Another specific type of classes in Java is the programming starter. The starters are classes that only have a main method. And as you know, obviously, main method is the first method that is called in a program. That's why we call that class a program starter. A common mistake for discovering classes that people make is that they turn classes. This is wrong. For example, paycheck is better name than is a better name than compute paycheck. So instead of using the word compute, which shows an action, it's better to just use paycheck as the name of the class, not any word that implies an action. So, in summary, the rule of thumb for finding classes is looking for nouns in the problem specification. For example, if you are asked to write a program that plays chess, chessboard, the word chessboard is a good candidate for a class, but move piece is not a good candidate for a class because moving a piece is an action and it's not a noun. Move is a verb. Another characteristics of a class is that it should have cohesion. A class should represent a single concept, and the public interface of a class must be cohesive, which means that all of the features in that class should be related to the concept that the class represents. For example, in this example that you see here, the class cash register contains some public constant variables like nickel value or dime value or quarter value. These are not characteristics of a cash register. These are features of features of uh, coins, and coin and cash register are two different uh, objects. So uh, it's better not to include these public variables inside the class cache register because of making a cache register cohesive. In order to solve the problem that I just mentioned in the previous slide, which was cohesion of we can do the following. We can break the cache register class that you saw in the previous slide into two different classes, class coin and class cache register. Then you can put all the features related to coins in the class coin and put the rest of features and methods that are completely related to cache register into class cache register. So here I introduce the concept of coupling. A class depends on another class if it uses objects of that class. So in this example, since cache register depends on coins to determine the value of the payment, we can say that cache register depends on coin. However, coin does not depend on cache register. Usually, high coupling, which means many class dependencies, is not desirable because it increases the impact of interface changes in classes. So it's better to minimize couplings to minimize the impact of interface changes. What does interface change mean? It means that sometimes programmers want to change the interface of a class for some reason, and if the uh, design of your program is uh, uh, high coupling, then you know you have to change so many different classes uh, because of one interface change in one class that it makes it very hard to maintain your program, or it makes it very hard to debug your program, for example. So it's better to minimize coupling. To visualize relationship between classes, we draw different diagrams. One of them, which is very um, popular, is UML, Unified Modeling Language. Actually, UML is not a diagram, it's a notation for object oriented analysis and design. So we use UML notation uh, to draw class diagrams and visualize the relationship between classes. This simple diagram represents the dependency between cache register and coin class. As you see in this diagram, cache register depends on coin. However, coin doesn't depend on cache register because there is no arrow starting from coin ending at cache register. Here is the outline of a high coupling design and a low coupling design. As you see in a high coupling design, the classes have many dependencies, and as I said before, it makes the cost of interface change in one class very high, and as a result your program would be hard to maintain and hard to debug and hard to change, and it makes it less reusable. However, when you have low coupling in a program, which means the number of dependencies between classes are very low, then changing interfaces in a class is affordable, and you just need to change a few other interfaces when you are changing one interface in a class. So, as I said before, cache register wasn't cohesive because some of its features deal with payments, but others deal with the coin value. So there is no cohesion between the members of cash register uh, before we broke it into two different classes. And as I said before, cash register depends on coin, but coin doesn't depend on cash register because none of the cash require the cash register class. So this slide introduces accessor and mutation methods in a class. Basically, your accessor methods are the methods in a class that don't change the state of an implicit parameter in that class. For example, if you assume that you have a class called bank account and you have an object from that class called account, then a method like get balance simply reads the balance of that account, and by reading an implicit parameter you're not changing it, you're just reading it, and then this method returns the value of account balance without changing it, and then that value is stored in another variable balance called balance, which is a double. So accessors are methods that don't change the state of any implicit parameter in the class. Mutator, on the other hand, are methods that modify the object on which they are invoked. For example, the method deposit on the same class bank account gets an integer or real number or whatever uh, type it can be, like 1000 as the input, and then it increases the balance with that amount. So when you call account.deposit, the method deposit will change the implicit parameter storing storing the balance, and it increases that variable or the value of that variable by $1000. This is how deposit should work, right? And then obviously, since it modifies the state of an implicit parameter in the class, it's not an accessor, it's called a mutator. So if a class has no mutator method, it is called immutable class. The class string that I'm sure all of you have used it before in Java is an immutable class, which means that no matter what method of string you call, you're not gonna change the object of a string that you have created before and you're using it. For example, if you create a string name, a string variable uh, called name, and you set it equal to John Q public with these, some of them are uppercase, some of them are lowercase, and then you call the method to uppercase on object name, uh, it doesn't change the value of name. All it does, it creates another uh, with the same, with the same letters, but all capital or uppercase. And then uh, we set it equal to another string variable called uppercase, but it doesn't change the name variable or the name object. Why? Because a string is an immutable class, and none of its method, including the uppercase, including to uppercase, is a mutator. All of its methods are accessors. it is safe to give out references to objects of immutable classes because no code can modify the object at an unexpected time because it is impossible. There is no there is no method in that class that can modify the object. In the similar manner, you can say that the substring method of a string class is an accessor, not a mutator. Any externally observable data modification of a method is called its side effect. For example, when you are calling the deposit method on a bank account, you're observing the change in the balance variable of that class, right? So the changing the balance is one of the side effects of deposit. Usually modifying explicit parameter is not recommended because it is surprising to programmers. Uh, we strongly suggest to avoid it if it's possible. So let's assume this example to see what I mean by modifying explicit parameter of a. In this method, we have a method called add students, and we are going to add all the students in this array list called the student name uh, to data structure in the class. So this is the code that is not recommended because in this loop, we are removing strings from the array list student names, and this method has some side effect on the explicit parameter because at the end of running this method, all the strings in the student names array list will be removed because of this line, and it will be surprising programmers who are working on other part of the class, and it may cause some bugs and errors. In this example, transfer method has also a side effect on both implicit and explicit parameter. It has it has a side effect on the implicit parameter balance because it reduces the balance by the value amount. It has side effect on the explicit parameter other because it changes the balance of other account. It actually increases the balance of other account by the value amount. So the side effect of this method is changing the explicit parameter other and changing the implicit parameter balance, which is a feature in the class that transfer belongs to. Another side effect of a method is the output that method may print out. So if you look at this method, it prints out some message. For example, the balance is now this much. So this method has a side effect on the output that will be printed out for the user. So it's better to decouple input and output from the actual work of your classes, and it's better to minimize the side effects that go beyond modification of an implicit parameter. So if you think you're changing the explicit parameter or you're printing out in the same class that you're working on the logic of your program, you have to think again and try to uh, redesign your classes, because side effects will cause a lot of problems and will make your program prone to bugs and errors. So if A refers to a bank account, then A.deposit 100 modifies the bank account object by increasing its implicit variable balance by 100. So it is a side effect, but this kind of side effect is common in object-oriented programming, and it's inevitable. And as I said, it's better not to have side effects more than changing the implicit parameters. But changing an implicit parameter is okay. But if you wanna, if your method has a side effect on the output or on the external parameters, I'm sorry, on the explicit parameters, then you have to rethink about your design and modifying something. So here we're going to talk about call by value and call by reference. When a method is called, um, there are two possibilities. Either the method can modify its own explicit parameters, or its explicit parameters are copied into some parameter variables when the method starts, and this way the method cannot modify its own explicit parameters. When method can modify its parameters, we say we have call by reference. If a method cannot modify then the method call is a call by value, not by reference. So Java has call by value. However, the method can change the state of object reference parameters, but cannot replace an object reference with another. So basically, you cannot replace uh, the object reference that is passed to you by explicit parameters, but you as a method can change the state of that object. Okay, but you cannot change, you cannot replace it, but you can change what's in it. You can change its implicit parameters and the state of that object. So some people think that Java method calls are called by reference, and as a result, they make mistakes like what you see here. So let's look at this example. In a class bank account, the method transfer is written in the following way. Basically, this method is responsible for transferring some amount from some other account to the account to the current banking account. So basically, balance. I'm sorry. Should transfer money from the current bank account to some other bank account. So you have to decrease the balance of the current bank account and send money to other account. So balance should be decreased by the amount. This is okay, but here what we do is the new balance, which is equal to other account dot balance plus amount. This is the new balance of the other account. The new balance is calculated here. Again, there's no problem with this, but here we say other account is equal to new bank account new balance. This doesn't work. Why? Because we are replacing other account, which is an explicit parameter of method transfer, with a new object of bank account. Since method calls in Java are not called by reference, this would not work. What you can do is you can change the balance to new balance, but you cannot replace it with a completely different object, with a new object. So this is an important fact that Java has, and many make mistakes. So you got to be careful. So as you all know, every method in Java must be in a class. And usually methods are invoked on an object. But this rule has an exception. A static method is not invoked on an object. So method. A static method is defined in the following way. You say a static method is not invoked on an object. It doesn't need an object to be invoked on. It can be invoked without instantiating an object from the class. So the question is, why should we write a method that doesn't operate on an object? There are many reasons. One that is very common is that doing this will encapsulate some computation that involves only numbers. You know that numbers in Java aren't objects, so you cannot invoke methods on numbers. You cannot say x as a number dot square root. This doesn't work. This is not legal in Java. So you want a square root to be a static method that is not called that doesn't operate on an object, so that you can actually call it without instantiating an object from a class. So here you can see an example of a static methods. We have a public class financial, and inside this class we have some static methods like percent of, which calculates the percentage. It simply divides p as the first parameter by 100 and then multiply it by a, which is the second explicit parameter. So this method is basically encapsulating this mathematical formula. So you can have many of these methods inside this class, but if you it's better to make it static so that you don't need to create an object of financial if you want to use these formulas. So whenever you want to call percent of in this example, all you need to do is call it with class name instead of object name. So you can simply say financial as the class name dot percent of, and then the two input parameters that you're interested in using them, and then this will give you the value that you're looking for, which is tax rate here by divided by 100 multiplied by total. Another application of using static methods is that normally if a method manipulates a class that you don't own, you cannot add it to that class. However, if you use a static method, you resolve this problem. For example, let's assume that you have a class called geometry, and inside that class you have a public static method called area, which basically gets a rectangle object and returns the area of the rectangle by multiplying its width by its height. So as you see, we resolve the problem like this by using static methods. Also, main is static. The reason that main is static is because there are no objects when you start your program. So if main is not static, you cannot call it at the beginning, right? So main should be called without having an object of the containing class. That's why main should be static. Also, as you know, square root is inside the class math. So the question is, assuming that Java had no static method, how would it be possible to get the square root of a number? To answer to this question, you simply need to first get an object from the math class, call it M, and then call a square root on object m, and then this would give you the square root of x, and then you can store it in another variable like y. But as you see, this is not convenient because you need to add one more line and you have to instantiate an object from the class math, which is simply nonsense. So it's better to have static methods so that you don't need to create an object of math, and simply here you say, instead of saying m dot the square root of x, you can say math dot the square root of x. Now in this slide, consider this example. You have a method called average, which calculates the average of an array list of numbers that is given to it by its explicit parameter. So the question is, why must this method be a static method? The answer is you cannot add any method to the array list class, because array list class is a standard Java library, so you don't own it, you cannot add to it, you cannot modify it. So instead, you create a public static method like average, and in that method, you basically do the calculations for getting the average, and sort of this way you sort of add a functionality to the class array list without owning it. In a similar way that we defined static methods, we can define static variables. A static variable belongs to the class, not to any object of that class. So for example, if you have a public class bank account and you have some, features like balance and account number, these are private, and you have another feature called last assigned number. This feature, if you call it a static, then you have to assign a number to it. For example, it's equal to 1000, and this variable, this feature that is static, is a feature of the class, not the objects of the class. So if the last assigned number wasn't static, each instance of bank account would have its own value of last assigned number. But right now, since it is a static, no matter how many objects you instantiate from the bank account, they all have the same last assigned number, because last assigned number is a static variable inside the class, and therefore there's only one copy of it for the whole class, not for each method, not for each object of the class. However, balance feature that is not static, therefore every object of bank account would have its own balance and account number, but not every object has its own last assigned number. So as you see in the constructor of the uh, bank account, we simply increment the last assigned number by 1, and this way we simply keep track of the bank accounts. But that the number of bank accounts that you have created this way. Okay, and then this will help you to set a unique account number for every bank account. So as you see in this figure, every instance of the bank account has a copy of balance and an account number, because balance and account number are instance variables, but all of them have only one single copy of last assigned number, which is stored separately. And the reason is because a last assigned number is a static variable, not an integer. So there are three ways to initialize static variables. First is to do nothing, and this way the variable is initialized to 0 if it's a number, it's initialized to false if it's a boolean, and if it's an object, it is initialized to null. And then another way of initializing it is to use an explicit initializer inside the body of the class. This is the example of the second way, which we saw before in the previous slides. You simply say last assigned number is equal to 1000 inside the body of the class. And the third way of initializing a static variable is to using a static initialization block. We'll talk about the static blocks later. The important point here is static variables should always be declared as private. You should not declare them as public. However, there's an exception in that rule. Is for static constants. If you have a static constant, you can either define it private or public. For example, in the class bank account, you can define a static final double overdraft fee equal to 5. And although it's static, but it's okay to be public because it's final, which means it contains a constant number. So it's better to minimize the use of static variables because it makes your program prone to bugs and errors. But static final variables are fine. There's no problem with a static variable that is final, which means it's constant. But if it is not final, it's better to reduce or minimize the use of those variables. Maybe the two most famous static variables that you all have seen before in the system class are system.in and system.out. So let's take a look at this example. Harry tells you that he has found a great way to avoid those objects in Java. The idea is put all code into a single class and declare all methods and variables as static. Then main can call the other static methods and all of them can access the static variables. So is this a good idea, and will Harry's plan work? The answer is it works because static methods can access the static variables of the same class, but it's not a good idea because Java is an object-oriented language, and there are tons of benefits in using object-oriented languages. But by using all static variables and methods, you are eliminating all the good things that object-oriented programming provides. So you're basically not using the capacity of Java if you're using only static variables and static methods in your program. Finally, at the end of this lecture, I'm going to talk a little bit about the scope of local variables. Basically, a scope of a variable is defined as the region of program in which the variable can be accessed. So, by this definition, a scope of a local variable extends from the moment that you declare it, or the line that you declare it, until the end of the block that encloses that variable. Because we have different scopes for different local variables, it is possible to use the same name for two variables in two different methods. For example, here in the method area, we have a double variable called R, and in a different method called main, we have another variable with name R, but this R is different from the R that we defined in the other method because they have different scopes. So it is possible to use the same name for two different variables if their scope has no intersection. However, if you have a variable like r with this scope, with the scope from the point that we declare it all the way down to the uh, end of the block that encloses it, and then inside that block we define another variable with the same name, then the compiler of Java has no idea uh, what R refers to. So basically, that would causes an error because you cannot declare another variable with the same name inside the scope of a variable with the same name. So this area is the scope of rectangle R, so you cannot define the double R in it because it creates ambiguity. But in this example, the scopes do not overlap. They don't intersect. So it is okay to use the same variable names. For example, double R is defined in this if, in this block, and in the else part of the same if, we define another R. This one is a rectangle. So the scope of double R is from here all the way to the closing braces of if. The scope of this R starts from here and ends at the closing braces of else. So their local the scope of the local variables do not overlap. That's why they can have the same name.